Don't tell me. No, it says text. Yeah. Yeah, totally good. I'm gonna get a slice of pizza, and then Hobson needs to hook up his laptop. You're not ready to go. Yeah. Okay, we're gonna get started in like 5 minutes. No, we're on YouTube now. It's starting. Stream started. It's still pre-show.
I'm having to convert my water down to
You'll move from there to I think it's not focused. Okay. Hello. All right, we'll get started, I suppose. We're good. You take your time. Yeah, I'm David. I'm one of the organizers of San Diego Python. You're in the right place for that. Sorry about the last minute audible in terms of the location. The other location, our normal location over at Building Q, was having some lighting problems today. So here we are. It's working here. So yeah. Anyway, I do want to thank Qualcomm for having us. So and specifically Urivan and Drew, who is Drew out there, making sure people get in? Okay. Well, Drew and Urivan specifically, they help make sure everything runs smoothly, letting us know that the lighting is broken in the room in advance. That's awesome. So thanks to them, and thanks to the engineering development team who they're kind of the ones who allow us to be here. So that's awesome. The pizza is sponsored by Cloudflare. I have to do a couple minute thing, but we will do that maybe in between the talks. Yeah, we'll do that. But basically, Cloudflare has paid for the pizza, so thanks to Cloudflare. Couple small announcements, and then we'll get into talks. You gonna be ready in 10 minutes, Hobson? Okay. There's a Saturday meetup for San Diego Python. It's virtual. It's on Discord. It meets at 10 a.m. on Saturdays. If you need to get on the Discord or you need any info, if you go to sandiegopython.org, you can get it. sandiegopython.org/Discord gets you to the Discord if you're not on there. It's a little different than this meetup. It's people in a voice channel. Some people are sharing screens, and some people are watching screens and then switching to other screens and things like that. It's more of a bring your own project, discuss what you're working on, that kind of a thing. There aren't usually speakers like this one, so it's a little different, but it's pretty cool. You can check it out Saturday, 10 a.m. As I said, the website, sandiegopython.org, there's a code of conduct on there. There's a YouTube channel, and the YouTube channel is linked from there. We're streaming this to YouTube. All the talks get streamed to YouTube, and usually by about a day later, they'll all have timestamps so you can skip through, because it's an hour and a half video, and you can just skip to the talks that you're interested in or whatever you need to do. Also really useful if you're 2 months later, oh, I saw this really great talk and I want to go look at it. It's there, and it has a timestamp, and you can just switch to it. The Discord has a jobs channel, so if you're looking for jobs, it doesn't get a ton of posts, but it gets some posts of local companies looking to hire and vice versa, that kind of a thing. There's other channels for like web dev, machine learning, that kind of a thing, if you're interested in those. Yeah, I do want to talk about some upcoming Python conferences, because that's kind of a cool thing to talk about. PyTexas, it's in Austin. It's next month, April 17th to 19th. PyCon US is in Southern California this year, so it's in Long Beach. May 13th to 19th. The main conference is the 15th to the 17th. There's a bunch of people from San Diego Python who will be there, myself included. So I'm not going for the full like 13th to 19th. That's too much. You're there too, Jorge? All right. Yeah, I know other people are coming. Trey's coming. Yeah, there's people. Pi Ohio is in Cleveland, July 25th and 26th. So that's pretty cool. And then DjangoCon US, if you do web stuff, Chicago, August 24th to 28th. So always cool to like promote things if you get out around the country or something. Like always cool if you just happen to be there to check it out. Or, you know, Long Beach is not too far for a conference that's going to have 2,000 Python people. So yeah, pretty cool. And the most important announcement of all the announcements is that you can become a speaker at the meetup. Very important. I'm highly motivated to do this because when we don't have enough speakers, like tonight, I have to prepare a talk. So I have a talk prepared for tonight on UV. But other people could give great talks. So please sign up to give a talk. Not that I dislike being a speaker, but I'm highly motivated to line up speakers so that, you know, I don't have to do that. So on the website, sandiegopython.org, you can sign up to give a talk. You don't even have to sign up for the very next meetup. You can say, hey, I want to do this like the next meetup or something. You know, it doesn't have to be a big long talk, 7 minutes, totally good. You know, if you don't want to take Q&A, you don't have to. It's pretty flexible, but, you know, and it doesn't have to be some advanced talk, you know, whether you're talking about some advanced pandas stuff, like that's okay. Pandas, anyway, the data science framework. You could talk about that. If you're talking about something more basic, that's great too. You know, the people who come to the meetup are all skill levels, so having talks at all skill levels is really important. So please, please, please sign up to give a talk. If you sign up to give a talk, I will be in touch with you, and then I will say things like, are you coming to the meetup? And then, you know, you show up and you give your talk. And then we record it if you want. You can not record it if you also feel self-conscious about it or something. Cool. I think that is all of my announcements. Hobson, are you ready to go? You could be the first speaker if you're ready.
Something like that.
Okay. And I'll be the second speaker. If you want, you could leave this on the thing, or you could clip it to yourself, or whatever you want to do. You just have to kind of, it has to be not too far from you. Oops. And then I'll let you do your intro.
I should have checked this first. Okay, great. But I need the screen to get shared.
Is it not? Oh, I didn't actually test that the screen is working.
No, me neither.
Is it? Yeah, it should be. Okay. Should be okay. But, you know.
I gotta figure out where did that setting go.
Did I not get this right? Okay.
It's not even popping up. Maybe I can hit this button. That's the deal. Damn.
We could try a different. I mean, we could bypass the capture if we think that's the problem. Or
I can restart.
Or you could try that. Or if you. That doesn't necessarily mean it's going to work, but we'll try it. I don't see anything coming up yet. Oh, I thought I saw a screen flicker there, but maybe not.
Shit.
Check definitely on. Reset the laptop. This may not be you. It could be this. Should we try maybe, like we could bypass this capture card?
Yeah, sure.
And see if it's a problem with the capture card. I don't think it is, but
It
you
never
know,
has
you
been.
never know.
Yeah.
You never know. Like things could be weird in here because this is not our usual spot. I didn't see anything happen there. So.
No, nothing at all.
Let's
go
make
back.
sure there's not some other HDMI over here. I didn't like grab the
Or an input switch where you switch between HDMI and other things.
Oh, that's just a dongle though.
No, I mean on the monitor itself, there might be. So.
Drew, you tested this thing, right?
Yeah, it was okay.
It was okay. I'm not like using the wrong.
Okay, then we're good. I'm just gonna figure out this.
Drivers? I don't think so. It's HDMI.
It's just my computer.
We're just struggling.
I'll just reboot.
You know, Linux is Linux, man. This is just. We're just Linuxing. Okay, so maybe we'll grab this. You're plugged directly in. Okay.
Yeah, just the big cable and the rat's nest.
Yep. Okay. Well, maybe if you're rebooting anyway, I'm gonna try with the capture card before I.
Of course. Might as well do it the right way first.
Yeah, we'll try it if we can get everything working. I feel like when we were at the place downtown, there was like always problems with the projector. And this is the right thing, so this should be coming out.
Did I put them in the right?
Yeah, this is right. No, you're all good. Oh, correct. Sorry.
It should already be popping up.
That's not good.
This is normal, but it doesn't. It gives me blind password entry.
Yeah.
From my hard drive.
You gotta do what you gotta do, but I'm surprised it's not done.
It takes a while.
Really?
Yeah, it's a bug in Ubuntu for their hard drive encryption.
I mean, I have full disk encryption. I'm using Ubuntu. It's immediate.
Yeah, well, my firmware update effed it.
It effed it. That is the thing. I will let you fiddle. The other option is I could go first on somebody else's laptop while you get this sorted.
Please.
Would you mind if I presented them? Drew,
By any chance you have your laptop?
I can go get it. But no, I'll be back.
I can do any laptop.
Mine freezes, so I don't suggest it.
My phone is all my devices are used right now. They're all.
You could use my phone.
I'll send you the PDF.
Can you try? I mean, if I don't know you can drive the presentation.
Let's do a laptop if we can. I will just send my laptop. I'll send my presentation to Drew because it's just a PDF. It's like 80 kilobytes, so it's very small.
Fuck. How did this happen? It was working.
Anything okay for a second?
Okay.
Oh, whatever you like.
So is your laptop not even booting up now?
I got it. It's booted up. I just can't.
Oh, it's
I can't find any settings that say mirror display, the normal stuff.
Okay. Yeah, you tried the whatever function, whatever that thing is. Sorry about this, people. This is what happens when we're not at the regular place, I guess. No dice? Oh, you're trying to.
Your Ivan's doing his own thing.
I'm just trying to see if
Oh, but I need this power.
we can get anything out of this guy.
Is it not connecting at all either?
No, one second.
Oh, I wonder if there's a problem with this thing then. We could reboot the projector if we want.
Right, anyway, it's right there.
AV system power off. Is that what we want? Oh, and the music came up. Sorry, you gotta get some tunes. It's shutting down still. Sorry for the tunes.
It's probably an automatic thing because, you know, auto let down when you're trying to prevent something.
We could probably. This is you? Alright, I will play this. Okay, let's touch screen to begin. Presentation. Stop. Okay, it's coming down. Any luck? I guess it's still moving the projector. And then this. Okay, and then the boot button on here is probably this thing. It's booting up, that is a thing. The projector still shows starting up. Oh, select a source below.
Where do I select a source?
Huh?
It's laptop, right? I mean, I think it's just like
Oh.
initializing or something.
Yeah, I guess so. That must be what it's saying. Oh, Pop OS, huh?
Since then, I learned it's better to do Ubuntu and then just do all the populous things.
Does anybody have one? A monitor I
I
can
mean,
try.
there's only that one. You can try it.
But it's
We
still not
rebooted the
alive, huh?
projector, so maybe that.
Yeah, we're waiting.
Wait, that. Oh, sorry. Any luck on that thing? Yeah, this is just attached to that thing.
Try moving it to a higher priority.
Huh, no dice. Very surprising. Oh, it's. I thought it's something. I saw something come up here, but maybe that's something.
Oh,
What's this?
that's just my.
You just have a device hooked up.
Oh, there we go. Woohoo! Something happened. If I can just get it to.
All right.
Hey. All right. I think we're good, Drake. Okay. Just watch your step. Don't trip on this.
Perfect.
But, yeah.
So I can unplug?
Yes, you can unplug.
Okay.
Yeah. Hey.
Can we get the lights off?
Yes, I will get that going.
Things always work right when I start hoping.
Yes. Thank you. You helped great.
Exactly. You're good luck.
Oh, how do I turn the lights off? I do not know how to do that. What's the button here? Oh, it's probably here. That's not too dark for people. Everybody's cool. All right.
Well, that's right. It's over on the other monitor.
Probably on the other display.
Yeah.
At least we rebooted the projector. Straight up Windows, man. Oh,
Wish I
hold
could-
on a second. Can I hate to challenge this, make this even harder. But,
Yeah. Go for it.
you're okay with it?
Yep.
We're going to do it.
Oh, yes, on the recording.
So we can stream. Got to get famous.
Yes, that is how that works. All right, hopefully the magic still happens here. Of course it is not. I'm not seeing any magic here.
Good eye on that connection thing. But it,
No, I'm not getting it.
damn.
I know. If we need to bypass it, we can just, we just won't have a capture of that.
That's fine.
Okay, well, we tried. We'll just do this and I'll switch to that and it'll be suboptimal, but okay.
There we go.
Okay.
Sweet.
All right. And then you have the mic. So, yeah, when you're ready, I'll let you take it away.
Let's Gotta get that. Why not? Okay. The Akasian game. Does anybody know what that refers to? What the Ikaso prefix might be referring to? What about an icosahedron? You'll learn pretty quickly here. What about these Hamiltonian cycles and Claude cycles is a new invention by Knuth as of last month when he used Claude to solve a particularly hard problem in one of his books about Hamiltonian cycles. He didn't use it. His friend, who's helping him write the book, used it, and just gave it a one-shot prompt out of the blue, and it helped. It didn't solve it, but it helped a lot. So what's so great about this kind of problem where you're searching graphs? Well, it's what you need to do when you're looking for the next move in a chess game, or the next token in a sentence, or the next atom in a molecule that you're building, like for drug discovery or AlphaFold, or the next chemical reaction as you're trying to manufacture a drug more cheaply by choosing the right chain of reactions that get you to the chemical you're looking for. It's called retrosynthetic analysis, when you're searching the graph backwards to try to find the chemicals that you need. So for the game example, this doesn't look like a graph, but it actually is, because at every point the knight has an option to move to a new square according to its rules. And the goal of this particular game, is called the Knight's Tour, is to occupy every single square on the board. So you can imagine if you're chasing a king around, you got to eventually be able to get to every square on the board in order to corner them. I don't think you can, but at least with a Knight's Tour is possible, and there's lots of solutions. So this is an example of a Hamiltonian cycle, because you eventually get back to the same square you started at, and that's one possible solution. It's a specialized solution of the coverage game. So a Hamiltonian cycle is when you cover all of the nodes in a path through a graph, and you reach the point where you started, so that you can do everything. It's like a traveling salesman problem. Knuth came up with a postulate about a particular kind of graph, and it turns out it's the graph that defines an icosahedron at m equals 3. And m equals 3 is the one that it's in the book that you first need to solve before you can go to the bigger numbers of m. And this discovery in February of this year solved it for all odd values of m. What is m? What is the dimensionality? The problem statement is here. I think I have a better view of that. I guess I don't. I'll have to rely on this. I'll read it real quick, just so you know how difficult it is to. The problem statement is 2 sentences. Consider the digraph a directed graph with m to the third vertices, ijk. This is the first part that tripped me up. What does ijk mean? It's the ID number for the node, and it's 3 integers in sequence. So in Python, that's a 3 tuple with 3 integers, and you got it. And I, J, and K are range m, which means 0 to m less than m, and 3 arcs from each vertex. So each arc coming out, each edge coming out of each node, there's 3 of them going out, and that means that there are 3 coming in as well. That's not stated in the problem, but that's just the fact. He gives the formula for how you define those edges. So basically, it's a generative math that says increase I by 1, and then mod it by m, or 3 in this case, if you get to the value to the 3, it turns back to 0. So it makes it, each one of these indices is going in a loop, really small loops, and you have to do that to all of them. And so that's the 3 of that's the 3. When I said 3 outgoing edges, there's one outgoing edge to I plus 1, there's one outgoing edge to j plus 1, there's one outgoing edge to k plus 1. And that gives you a power of 3 on that, so anyway, that's enough about that. So the first view of this is to, you see the first drawing I did when I'm first thinking about this. I did it in, that IJK forms a natural grid, a Borg, basically, of integer positions in a cube. So I tried it with n equals 2, which is not possible. So it's not possible to do a cycle or partition it into 3 cycles. That's the goal. And but it helped me understand the problem and how to increment all these indexes. And so that's the first thing that so this is for m equals 3. This is the full graph of that of this Icosian problem that goes back. By the way, this goes back all the way to Greeks and Egyptians who would produce these icosahedrons and try to solve this problem themselves. And I'll explain why that is. I'll explain why this was the first ever graph problem, according to Newt, that people actually legit formulated as a graph. They realized that, this is a connection between all the sides, in this case, of an icosahedron. But this graph doesn't look at all like an icosahedron, and I'm afraid I don't have any examples. But fortunately, you'll all have one in your head as soon as I tell you what it is. First time I asked Claude to give me a Plotly diagram, it came up. It was this, but it was missing all of these stubs, these incoming and outgoing edges that are arcs going back and actually fulfilling the loop. So you go I plus 1, I plus 1 again, do mod 3, and you end up coming back here. And it forgot them entirely, and it said, oh, that's just because I hid them behind the solid lines with dotted lines going directly back. And so first lesson I learned is Claude can't see. It has no idea that it's not some. It put those lines in there, and it doesn't care whether they're visible or not. That's not part of its problem. Next time I asked it to do this, this is what it came up with. But gradually refined it to the point where it's actually usable and useful, trying to see those edges that are arcing back around and making it presentable. This is his paper, just a URL to it. I'll try to share the slides. So an icosahedron is not a dodecahedron, but they are two things that you've probably seen a lot of if you play any role-playing games. Anybody now know what they are? Yeah, so can anybody guess which of your dice each of these are? 20 is correct. That's the icosahedron. The dodecahedron, actually, I'm not sure. I asked a question I can't answer. One of them is 12-sided, one of them is 20-sided. And they are what's called a dual in graph theory, meaning that a dual shape or a solid, because one of them will fit inside the other, but the 20-sided die will fit inside the other way around. 12-sided die will fit inside of the 20-sided die, and the edges of the 20-sided die connect the faces, the center of the faces of the 20-sided die. It's an exact match up. And so they're just two different graphs that are kind of isomorphic to each other with a transformation. This is back to the practical examples. Why do we care about graphs? ORD is an open reaction database, which it turns out to be a graph of 2 million nodes of those reactions that created that particular chemical. So it connects up a bunch of chemicals that are useful in pharmaceuticals. Smiles is a representation of a molecule. It's a language, and the next token in the language is an atom that you can add or subtract from an atom or a molecule in that AlphaFold prediction. And so AlphaFold was trying to predict smiles, and smiles has a grammar, and that grammar defines the physics of the world, quantum physics. So if you can predict the next token well, then you understand physics. And so a transformer can do that. So AlphaFold can only predict it with very, very low accuracy, but it's enough to give it a nudge over combinatorial search, which is what what people are doing to solve most graph problems deterministically and reliably. Okay, so let's talk about a little Python. So this is how I wrote it up in Python. It's really quite simple to create the graph, to generate the graph in Python. Mine's a little more verbose than it needs to be, but M, we've talked about, that's the number of, have we talked about it? That's the number of steps you make on each of the integers, and it's proportional to the cube of the number of nodes, and the dimensions is that IJK. So you can do this on IJKW, whatever. You can do it on multiple more dimensions, but I've only ever seen it done on 3. And it's the only one that really matters because in the 3-dimensional world that we live in. And so here's how you generate that graph, in case you want to plot it in network X or whatever. And I was hoping to actually show the icosahedron that comes out of this, but can you guess how many nodes and edges there are for m equals 3? This is like the complexity analysis. You're trying to figure out. So m occurs 3 times, and the 3 occurs a 3rd time here, where you're just going through those 3 edges going out from each node. So this defines, these 3 define the number of nodes. These 3 add additional, there's a multiplicative factor of 3 on the edges. So now can you get it? What is it?
27 nodes.
Good.
27 times 3 edges.
Perfect. And 81 edges. Just a Python tip in case some of you are your eyes are glazing over about graph theory. This is a nice trick in IPython, the interactive Python REPL, where you can get a history of everything you've done, and that's how I wrote this program. I just wrote it one line at a time and then exported it to a Py file, or in this case, or an IPy file that you can edit and make better. So you can get your history and record your history back to, whenever you first installed IPy. Actually, even before you first installed it, all the way back to the first time you installed it and reinstalled it, all that stuff. You have all your history of everything you've ever done. You can find it and search it and get some good, useful ideas out of it. Okay, so of course I couldn't resist asking it the same darn question 2 months later after they've surely trained it or fine-tuned it on additional examples of solutions. And I wasn't the only one. Those thousands of other people, you could see in his paper, a lot of people started working on this as well. So this is the problem I posed it. This is the exact same, this is just in LaTeX, that exact same text you saw earlier. Because that's what LLMs understand when you're trying to give it a mathematical formula, you better give it in LaTeX, unless it's Python. So this, of course, it calls back on how excited it is and how awesome you are and all that sycophantic BS. And then it corrects your LaTeX, and then it goes off. And I did learn a little bit about some things. He says something about, oh no, they didn't introduce anything new here, but here he did. You mentioned this thing called a Cayley graph. You can look that up on Wikipedia. It doesn't look at all like these graphs, but it's a group theory, category theory concept that this is a member of that particular group of mathematical objects. So anyway, it's going on and giving me, these look but much better rendered and, as LaTeX. But it does get the number of arcs and number of edges correct. And this is its proposed, the construction is the algorithm that's not going to generate the graph, but to generate the paths, the 3 paths that it's looking for in the graph, the 3 loops, the 3 cycles. And so this was its solution. So this is the first of those 3 cycles that you can use using this thing called a scanline pattern. Don't know if that's hallucinated or not, but this is the pseudocode for that algorithm that it thinks will work. Don't know that it will, and even and then it just says repeat that, just incrementing through I, J, and K. You just permute the I, J, and K indices in that algorithm and do it again for the other 3 cycles. And it should work, at least according to Claude. So then it asks you, so what do you like to do? Do you want me to generate some code to verify that those work? And that's what, so this is how Philip, Knuth's friend, solved the problem. He said, instead of just giving it the prompt, he also said, generate the code, check the solution, and try again. And each time you try something, record what you've done in this plan.md file. And so he gives them, so that it will, because it's in planning mode, it's designed to always read that file before it does the next thing. And he has to be really emphatic about it. And don't ever do anything without first recording what you've just done. You know, you have to really coax it into doing the right thing. So that worked in the sense that it got through about, I think, more than 30 attempts at solving it. This was just one that I showed here, the first attempt. And so it did 30 more attempts, actually implemented them in Python, tried to see if they were actual solutions. You can verify it just by running the code and seeing if it touches all the edges, all the nodes. And on the 30th try, it found the solution, which solves it for all odd M. Not all M, which is the problem statement, but all odd M, which is still a major accomplishment. And so that visualized question is what I just showed you earlier, where I had it produce those Borg-looking things. That only took 42 seconds, so obviously it's been primed with this question in the past couple months. Because when I told it to go on, it says, so I prompted it with exactly what it had said it could do, and this is what happened. It gave me an error after an hour of chugging away at it because it was trying to compress all my history. To be fair, I've been doing a lot of AI research before this particular problem, so it had a lot of history to deal with. But it basically it doesn't have a lot of
Don't tap that.
understanding. Oh,
That's the microphone.
it doesn't have a lot of understanding that or memory. And so I reset that setting and quadrupled it and started over again in a new session. And this is the solution that I just described to you that Philip did. And these are the visualizations. Okay, I think these are just duplicates. We're almost done. I've already covered all of this. I put this in the wrong order. We've talked about all of this. Oh, some other terms that you might like to know. All of this stuff, generators, when it talks about a generator or a constructor, those are algorithms, obviously. But less obviously, they are generative models, and they are deterministic. They will always work or not work. And so once you've done it once, you never have to do it again, once you've designed the algorithm. Is it generative AI? Absolutely not. Generative AI is probabilistic, and sometimes they'll get it wrong, sometimes they'll get it right, and you never know when it's going to be right and when it's going to be wrong. There's no way to verify it. It is what's good old-fashioned AI, what's called an agent policy. It does represent something that you could physically do. If you're playing a chess game, you would follow the algorithm, and that would be your policy for every move. That whatever node you found yourself at, you would make that decision that's dictated by the algorithm. So it makes a great agent policy, not agentic AI, but awesome AI agents, good old-fashioned kind of AI. And gameplay strategy, obviously. Each of those algorithms is a strategy that you could employ in a game centered around that. And that's what the Akasian game was. Forgot to mention what that is. It's that 20-sided, yes, the 20-sided die. That's why, so the 20-sided is the icosahedron because it's the Akasian game that the Greeks came up with when they were carving out a 20-sided die out of stone and trying to figure out how they could label it with the first 20 letters of the Greek alphabet on the faces that were adjacent to them. So they were looking for not 3 cycles, they were looking for 1 cycle that would cover all of the faces, which is the equivalent of doing that on the edges of a 12-sided dodecahedron. Finally, I get it now. Just remember, all you have to remember is the Akasian game and think, okay, how many letters are there in the Greek alphabet? There's more than 20, that's for sure. So they had to be using something that was 20-sided or more. And that'll get you to the story. And Knuth has some really good photos of those die that he found, dug out of the British archives of from ancient Greece. In case you hadn't heard, look for Light LLM in all of your packages. If you used UV, you can find it in anywhere in your lock file. What was that, Juan?
UV lock file.
Yeah, there's a UV lock file.
It's safe to use now, just make sure you're using the same version.
Exactly. Just make sure you're not using either of these 2 versions, 82.7, 82.8. It will take over your computer and take over your life. It will steal everything of value on your laptop, and you will never know it. It'll use up a lot of RAM and a lot of CPU while it's doing it. So as soon as you install it, and then it will persist for the lifetime of that laptop until you fix it, until you eradicate that virus. It's an extremely well-designed APT threat-designed virus. And it was up on Pipey for 2 hours. And when you're serving millions of people a day, that's a lot of people who got hit hard. And it's installed as a dependency of dependencies, a secondary and third dependency of things like RAG, graph RAG, and a lot of the tools that I was using. Fortunately, I never installed it during this window, and I was safe. I couldn't find any of the persistent scripts that it's supposed to hide on your computer.
I'll talk more about this in my talk.
Oh, good. Well, that's right. I've taken up a lot of time.
No, you're okay.
Any questions?
You're fine.
Yes.
All right, so I have a question. So the one that you showed was worked when it was on. Is this going to work if you take any three odd segment groups and take their direct product and look for these paths on the Telegram?
Yes.
Okay, so if I do like C3
What did you call that? You called it a directed product?
direct product?
Oh, yes. Okay. That's the right term I should have been using. Okay, good.
So if I did something like C3 cross C5 cross C7 and then built the Telegram on that, I would still be able to.
Exactly. Oh, and Philip did it manually, or he wrote the code that would do it and test it on all the way up to 16, including the even numbers. So it is possible for a human to see the pattern and the algorithm that will, where you can hard code the algorithm up to 16. Darn it. I forgot to mention that the solution that Philip found was actually improved upon by a reader of that same problem. As soon as people heard that, oh, it's been solved, of course, everybody jumped on it, and they improved on that solution a lot in terms of making it even more concise than it already was, an actual implemented algorithm. And that's the one he's going to publish in his book. And it's general for all odd. I don't know, but considering that it works all the way up to 16, that's why Newth is pretty sure it should work for all m. Works for evens up to 16, and it works for odds up to infinity, so it should work for everything up to infinity. It's just hard to check at infinity. Any other questions?
While we're taking questions, there might have been a problem between my laptop and my chair, as in my problem, and I think this may work now. Come try it. Example. There we go. Oh, sorry. Oh, I ripped that out of your laptop. That's not
No, it's designed that way.
Let's see if this just works. It might. It should.
famous last words. Oh.
Did something happen?
Oh, something did happen, but I don't know if it was me or you.
Hey. Yeah, the problem was between my laptop and my chair. Sorry. Hey, look at that.
Okay, great. Oh, another word that I learned in the course of this is torus. Couldn't figure out what the heck, how a torus. These things didn't look at all like a torus, but those are. Those cubes are toruses in the graph world. You understand this probably. An example of a two-dimensional torus is the asteroids game, where the asteroids fly in from one side and come back around to the other side. That's why it's called a torus, because if you actually connected those edges, the only shape you can do that does that, where both the top and bottom are connected, that's a two-dimensional torus, and it looks like a donut. It's just that the long way around is the grid cells have to be expanded a lot for the scale to be the same as the small way around in a donut case, or you have to make it a really fat donut. What else? I have no idea what a 3D torus would look like. How do you wrap three-dimensional space with a wormhole back around to the other side of three-dimensional space? I have no idea.
Chat would like you to know that it's Zodec is 12. You figured that out.
Okay, good.
They confirmed it.
I'm glad it knows at least that much. I'm glad it can count to 12.
Oh, no,
Yeah,
like
good.
people on the live stream, not ChatGPT.
Good. The
People,
chat, the
humans.
real chat.
Yes.
Got it. Nothing more that I can think of that I learned.
No, leave it there. Yeah. I'm gonna do stuff on your
Oh,
laptop,
right.
if that's okay.
Right.
Just don't trip on this mic table.
I need to find your stuff.
My 2 PDFs.
Yes.
Cool. Well, thank you. I guess we'll do maybe the Cloudflare one first, and then, but we could open both PDFs. I don't know where you put them, but
Yeah, I
they
know.
should just be files somewhere.
Yeah, they're right here. And they
Oh,
are.
you're on the. It's on the other screen.
I know. I gotta.
You're just using two screens.
I've got to use the screen. Yeah, right now.
That's cool. Don't worry about
What do you remember the names?
it. One is called like Cloudflare or something.
Yeah, there's
That's that
Cloudflare.
one. So open that one first. And the other one is called, I think. I'll get the name. The other one is Short Deep Dive on UV. Capital S. That matters. Okay. Hey. All right. Well, we'll do the other. We'll do the Cloudflare one first.
Can you do the?
I can do it. I can figure it
look,
out.
look over your shoulder.
Yeah. Do you want to take your glasses? Yep. All right. Okay. I can do this. I can do this. Thank you, Hobson. I'm glad we got our my problems worked out, I suppose, and this will hopefully just work. Okay. Awesome. So I know I mentioned this earlier, but the pizza is brought to you by Cloudflare, or brought to us by Cloudflare, or brought to somebody. Cloudflare paid for it. Cloudflare makes networks and websites faster and more secure. They provide awesome tools like web app firewalls, DDoS protection, R2, which is an S3 compatible storage layer, and much, much more. Cloudflare network is absolutely massive, and 95% of internet connected people are within 50 milliseconds of a Cloudflare node. And this makes your site or network fast for people all around the world, which is super awesome. There's a bunch more features that I did not mention. You can check them out on cloudflare.com. The free plan is very generous. The SD Python website uses it for storage. So like, we're using Django, and then the storage is stored on R2. So thank Cloudflare. And yeah, I think there's, oh, okay, yeah. And then they have lots of stuff. Websites, yeah. I think this one's all about hiring people. Anyway, thanks, Cloudflare. And then I have the next talk. Hopefully this, no, all right, that didn't work, but yeah, we'll just do that. And then I have a talk on UV, and hopefully, do you think there's a presentation mode? Probably not. We'll just scroll. You think there is? Maybe there is. No. Yeah, whatever. All right, whatever. We're making it work. We're scrolling. Okay, so awesome. I had to give a talk because we didn't line up another speaker. So here I am. I let people vote on it, and more people wanted to hear about a short deep dive on UV. Actually, I'm going to just make sure that the audio video is right here. It's good, I think. Yep, we're good. Okay. We're good. So this is what people wanted to hear about. Who has heard of UV in the room? All right, probably about half of people. Okay, awesome. Oh, hey, this is just working. So what is UV? That's a good question. So UV describes itself, like on their website, as a fast Python package and project manager. And I will dive quite a bit deeper into what exactly that means. But basically, it brings together a bunch of functionality that existed across a bunch of different tools in the Python ecosystem. The big one being pip, but a bunch of other tools used with pip. Pip is used to install third-party Python modules, typically, like pip tools, which could be used to pin dependencies or to upgrade dependencies of your package. PyEnv, which was used to kind of have these segregated environments. Hey, I have this project running on Python 3.12, and I have this other project running on Python 3.14. They have totally different dependencies, all sorts of things like that. VirtualEnv let you have these isolated dependency environments. It does a bunch more than that, so all the functionality of all of those tools and more. It's created by Astral, who as of a week ago were acquired by OpenAI. It's unclear what that means exactly. Astral does not make money, so why were they acquired? These are open questions. The answer is probably to build cool things like UV for OpenAI. What will happen to UV? I don't know. It's open source though, so the worst case is somebody else has to take it over, is the way I see it. UV installs both Python dependencies and Python itself, Python versions itself, so it can install Python 3.14. If you need to try out the Python 3.15 release candidate, you could do that. All sorts of things like that. I don't think 3.15 is all the way out yet. It's heavily optimized for speed. It is much faster than the tools listed above, typically 10 to 100 times faster. Kind of depends on exactly what you're doing. I will dive into that a little bit actually in this talk. And then if you are familiar with other languages, other package managers from other languages, it took a bunch of the good ideas from those while also not taking some of the bad ideas from some of them also. So it's good. You could think of it as like a modern Python packaging tool, you know? So what does this mean in practice? What is this, like, why should you care? What do you use it for? So previously you had pip, you installed your project dependencies. You had pip tools, you created a lock file, maybe. This lock file had hashes, maybe. You could update your dependencies with it, definitely. Pip tools did do that. PyEnv let you have, as I said, kind of these different Python environments. A virtual env let you create virtual environments. All of this is replaced with kind of a single command with UV. So UV sync, if you've defined all the dependencies of your project, this all will just, it can install Python if you don't have it. It will install all your dependencies. You can have your dependencies broken out into mandatory dependencies, optional dependencies, development dependencies, all these sorts of things. And it will do all of that. It installs them from a pyproject.toml file. I'm actually going to put this on so that my audio is a little louder, which is not a format that they created. This is a standard across Python. Other Python tools also can install from pyproject.toml. But one of the things, and I'll get into this, that makes UV faster is they didn't support all the backwards compatibility with all those other ways to do this. They support pyproject.toml, and if you don't use that, then you don't, is kind of the answer. It always, always, always creates a lock file, kind of, or you could probably make it not, but you would be fighting against it. It always creates a lock file. The lock file contains every version of every dependency, including transitive dependencies, including cryptographic hashes for all of those dependencies. And this includes, even if those dependencies had, say, you know, a different version on Windows and a different version on Linux, you have kind of architecture-specific files or something like this, it has the cryptographic hashes for all of those files. We will get into this a little bit because we were talking about supply chain attacks in the previous talk a little bit. I'm not going to deep dive into supply chain attacks, but I have some interesting things on supply chain attacks in here. And UV will not solve supply chain attacks for you, but it helps a lot, is kind of the way I'll put it. So in that pyproject.toml, you can declare, hey, I need this specific version of Python, or I need this range. I don't support below Python 3.12 maybe, or something like this. UV will install it if it's needed, or you can tell it not. You can tell it, you know, error out, don't install it. UV has lots of options on this. And it will create a virtual environment by default, and you can use that virtual environment. It will be pegged to that version of Python that you declared. If you've never seen a pyproject.toml, and I realize this is a little small, sorry about that, this is what it looks like. And this has some interesting parts in it. You can see here, oh, I guess I'll get the mouse over there somewhere. Nope, I will not get the mouse over there. Nope, oh, here it is, the mouse. You can see I kind of declared the version of Python that I wanted. I declared some dependencies. Some of these dependencies had ranged versions that it supported. And then I have maybe some development dependencies. A lot more things can go into a pyproject.toml. Almost any Python tools configuration can go into a pyproject.toml, and it can be read out of there. And one of the really nice things about pyproject.tomls is you can parse them deterministically without running a Python interpreter. So if you remember what Python packages were like before this, you had a setup.py or something like this. You do not know what the setup.py executes Python code. You have to execute Python code in order to determine the dependencies of the project or determine what versions of Python it required, which then you had to already execute the project in order to determine its dependent. Lots of circular problems here you can kind of see. pyproject.tomls do not have these problems. If you have a parser that can parse this specific language, toml, it can parse it. And then you can read it. It's in a deterministic format. You'll figure it out. Anyway, and the Python standard library includes a toml parser, but there are other ones.
And UV is compiled Rust, so
I will get into that. That you're getting into my why it's fast, which is later. That's one of the last slides.
that's why you can do this. It can parse the toml file without having a Python interpreter.
True. Yes, correct. I also put kind of the commands at the top here. So UV add adds dependencies to your project. UV remove removes dependencies. UV sync syncs your virtual environment to the dependencies that are declared. So these are some of the commands. UV does not actually have that many unique commands. It's only about 20. So I will discuss probably 15 of them, of which on a monthly basis you probably need 7 or 6. Like, you do not need very many. You can run a script with UV in an isolated environment or in the same environment as your project. Interestingly, now in Python, you can declare dependencies, even the version of Python that it should run with, in a deterministic format at the top of your script. And even if you're not in a project, you just have a single file, you can type UV run this file and it will run. It will get the version of Python if it does not have it. It will get those dependencies if it does not have it, install it into a one-off virtual env, and execute this script. This works. So I tested it. I did it. And it will not overwrite your current virtual env. So if you're in a project and you have a script and the script requires dependencies that aren't project dependencies, that will be OK. They will not be installed into your virtual environment. And it can use a different version of Python even than the project that you have. So this is very flexible. It's very powerful. This isn't a UV-specific functionality, but pretty much only UV implements it, is kind of the real answer. But this is actually a Python standard. I put the link to the actual packaging.python.org thing in there. I mean, this is a pretty simple example, but it uses a third-party module. So I figured I'd show an example. This is some of the cool stuff that UV can do. If you have a script and you know somebody has UV, you can give them a script and they will be able to run it. Pretty much, period. Cool. UV has a bunch of other useful features. UV lock is the thing that creates a lock file, although if you do almost anything, it will create a UV lock file for you if you have dependencies declared. The lock file, as I said, has all the dependencies direct and transitive. So for example, when a supply chain attack like this comes along with Light LLM, where there's 2 specific versions, hey, if you have those versions, you've kind of already been got, essentially. If you can grep your lock file for these. If your lock file does not have these, your project did not install these. That is how that works with UV. So UV will install out of the lock file. Every dependency is declared in the lock file. So that's kind of nice. You can use UV lock upgrade, and this is where some people got into trouble. If you're running UV lock upgrade automatically, and say a Light LLM vulnerability is in PyPI for 2 hours, and you run UV lock upgrade in those 2 hours, you got it. You know, it upgraded to that version that is bad. UV lock upgrade respects the version constraints. So for example, if you look back at my pyproject.toml here where I said, oh, install Django 5.2, but less than 5.3, it will respect that. So if you declared your dependency like that, somehow this is not doing that anymore. Whoopsies. But if you UV lock upgrade your dependencies, notably, UV lock upgrade has a very nice feature where you can say exclude newer and give it a timestamp, like say a week ago, and it will not install any upgrades that have not been sitting in PyPI for at least a week. Useful feature, especially if you are trying to avoid supply chain attacks. Let other people be your guinea pig for a week. Interestingly enough, my company implemented this like 3 weeks ago. So we'll, just in time, I guess. Perfect timing, very lucky. Yeah, kind of interesting, or yeah. Cool, so I talked about UV lock upgrade. There's UV tree, which shows your full dependency tree, every single version, all the things that every dependency you declared, every transitive dependency of all of those things, transitive dependencies, et cetera. You can look at, okay, let's say I know something is in my environment, what packages relied on it. UV tree can show you that full dependency tree and just display it. It kind of, yeah, go ahead.
Sorry, transitive dependency?
So a dependency of a dependency. So a dependency that you didn't declare, a transitive dependency is a dependency that you didn't declare, but that one of your dependencies needed. Yeah.
Sometimes they're referred to secondary dependencies.
Oh, okay. I've never heard it called that, but I believe you.
Yeah.
All right. UV Python list and UV Python install, this is how you kind of manage the versions of Python that UV already has installed. If you want to pre-vet the versions of Python that you're letting it install. You can do that. You can delete versions of Python if you decide, hey, I'm never going to use these, or you want to try out some very speculative version of Python. You can use UV to install stackless Python or MicroPython or all these different versions of Python that you probably don't want to be your main Python interpreter because they are heavily restricted in some ways. UV build and UV publish replace something I didn't even mention in the tools, but this is how you publish packages to PyPI. So you can use UV to do that directly from, if you're building a module yourself as opposed to like an app or a project, you can do that. UV audit is new, literally in the last, I think, week to 10 days. It is brand new, feature subject to change. But this actually checks all of your dependencies, including transitive dependencies, for known vulnerabilities. So it's not code scanning anything. It is literally looking at your dependency tree, looking at a graph of what are the CVEs for versions of things. Do any of the versions that you have declared have CVEs against them? CVEs are just basically a common vulnerability enumeration. I don't actually know what the E stands for, but basically the government, NIST, when a big vulnerability in a software package comes out, they issue a unique identifier to this vulnerability. They get published. It also looks, in addition to CVEs, it looks at the GitHub advisories and the same kind of things that Dependabot looks like if you've been spammed by those. But UV audit will basically check your dependencies and do this. It's very fast, and you can add it into your CI. Be careful though, because you can just have your CI fail, for example, for like 4 days. Concrete example, pigments, which I'm using that in this presentation to syntax highlight my slides here. Pigments has a CVE that is open against it. There is not currently a fix. I'm not really worried about it because I'm the one who's supplying the code for it. I'm the one who's supplying the code that it should syntax highlight. But there's no fix for it. A fix is not expected for about 2 or 3 days more. The fix is merged into main, but they're not going to have a release for it in 4 days. If I had this running in CI, basically my whole CI pipeline would just be failing for 4 days. So, you have to kind of think about exactly what you're trying to solve with this. But, I know that because I ran UV audit on my code, saw that there was a vulnerability, and UV helpfully told me there is not a fix for this currently. So it goes. But yeah, UV audit, literally brand new. I will tell you, I read some very detailed things on supply chain attacks earlier in the month, the beginning of the month, and UV audit did not exist at that time. It was just a proposal. And then I looked today and I was like, oh, UV audit exists now. This is great. When I was preparing this talk. Almost everything in UV can be controlled with environment variables. I mention this because this is extremely useful when you're running this in Docker files or in certain environments where maybe somebody else, some other thing is running the UV command for you and you want to kind of change UV's functionality with an environment variable instead of something else, instead of changing the options that you've passed to UV. It also has really well documented integrations for Docker. How do you run UV in Docker? How do I run my application with UV in Docker? How do I do it in GitHub Actions? I put those 2 examples, but there's a bunch more examples. How do I do it in GitLab? How do I do it in, literally, there's 20 documented examples of this on the UV website. So if you go to the UV website, which I have a link to in a sec, it has a lot of those. I do have a slide on why UV is fast. It is written in Rust. That is a big reason why it is fast, but that is not, I believe, the primary reason why UV is fast. Rust is faster than Python. I will not dispute it, but I do not think that is entirely the reason. I think that is at most half the reason. It has dropped support for a bunch of things that you probably don't care about in Python packaging, like eggs. Nobody gets their eggs from the cheese shop anymore. If you know what that joke is, you're old. Congratulations. It doesn't have setup.py. That same thing. That's okay. It probably does. There's probably some option for it, but whatever. Most of these things, those are all fallbacks rather than pip tries a bunch of things and has to go through a bunch of iterations. UV mostly does not do this. It downloads things in parallel. That's smart. And this is probably the biggest reason why UV is pretty fast. if you have to download 30 packages for a brand new project, you have 30 dependencies, including transitive dependencies. It is making 30 downloads in parallel as opposed to doing 30 serial downloads, downloading one, then downloading the next, which is how pip works by and large. It also caches packages very aggressively and uses hard links, which basically means there's a way in most modern computers to just say, I have my file in one location and I have 2 different instances on the file system that point to the same file location. There's a way to do this, and it does not copy the file. It just makes a link to the file. It is much faster than that. It saves on bandwidth because you don't re-download the file. That's much faster. And it saves on disk copies. And so that also makes it much faster. These are I think these are the biggest reasons why it is faster, although Rust is not a negligible reason. That is also a reason.
And hard links never break. You can't break them.
You cannot break hard links. That is true. Yeah, so unlike a symbolic link, if you've seen a symbolic link and the file doesn't exist anymore, as long as something links to the hard link, as long as something has a hard link to it, it's there. It has not been deleted from the underlying file system. That is how hard links work. That is correct. Yep. Yeah.
Hard links don't, with UV don't work across disks. So those get copied. So if
Yes.
you have the cache on the C drive, it'll copy it to the D drive instead of making hard links.
That is true. Yes. It also has a lot of issues if you're doing it into like virtualized file systems like Docker. Those usually involve copies. So yeah, so you're right. Yeah, when things cross sort of a file system boundary, things get weird. UV will usually figure it out and handle it automatically, but it will be slower, is kind of the real answer. Not like drastically slow. You're still copying files on a disk. That's usually much faster than downloading them from the network, with some exceptions. Cool. I have some links to some things. I did want to talk a little bit more about supply chain attacks, which I have a link to. There's the UV homepage, the Docker and GitHub Actions integration. I put a link to the script metadata. That was the thing where you could declare both the Python version and dependency versions at the top of a script in a comment. There was a really good blog post on UV, how UV got so fast. It talks about those things I talked about and more. And then this is actually just a very timely post that I had read earlier in the month about kind of practical guide to Python supply chain security. It came out like literally in the early part of a month, at more than 2 weeks ago. And then lo and behold, what is it, yesterday or the day before, we have a very, very serious supply chain vulnerability in the PyPI ecosystem. The end result of that Hobson talked about. The end result of that, though, is I was extremely impressed with how PyPI handled it. Literally, a vulnerable package was up on PyPI for just hours before it was totally quarantined. Nobody could download it anymore. I was really impressed. But this post talks about a lot of the things, basically, that help you avoid these kinds of supply chain vulnerabilities. And one of the things it talked about is using UV. UV, the fact that it has lock files, right? A requirements file doesn't pin the exact cryptographic hashes. It doesn't necessarily store all the transitive dependencies. There's lots of things that it misses. UV lock files have all of that. So UV helps you. It will not solve your supply chain issues entirely, but it has features like when I'm upgrading my packages, don't take things newer than a certain date. These are options in UV. They're very powerful. You can use them. And this post here from, this is actually a link. I'll post these slides up on, I'll put them in the comments for the video. This is actually a link. And the post has it was very long. It took probably 2 hours to read and really understand everything that was in there. A lot of it is stuff that you might know, but you really put it into some concrete steps. I didn't agree with all of it, but it was still good. Loved it. It was awesome. And I think that was it. Were there any questions about UV or anything supply chain? Go ahead, Drew. So let me make sure I have the question right. You're saying if there's a project, even from the file system, As long as it has a PyProject.toml, whether it's on disk, whether it's just a zip file, whatever, will UV install it? Yes. Yeah, yeah. So UV can still install things, yes. So the answer to your question, can it install from a GitHub? Can it install from like a zip file? Can it install? Yes, it can. It can absolutely install these as long as it's packaged in kind of the modern way. Yeah, go ahead, Jorge. Yes. Yeah, so Jorge was saying UV supports editable installs, which is when you're installing like a local version of it that you have on your file system that you are making modifications to kind of actively. They call this an editable install. Yeah, yeah, go ahead. I do not know how that is handled exactly. Different C extensions handle this differently. So or at least I've seen it, like CFFI doesn't require that. But I do not know. I actually kind of suspect that UV will install a setup.py. I know I said that. I kind of suspect it will, but it will do this under kind of like a fallback mechanism rather than the primary mechanism. So I kind of suspect it would still work, but sorry, somebody, I didn't. Yeah, maybe. Yeah. So UV has some subcommands, but I actually think UV, like if you did a UV add and you passed like a directory that just had a setup.py, I kind of suspect it would work, but it will probably, that would not be the most optimized code path. But I suspect it would still work. Any other questions on UV? Do you have another one, Jorge? Yeah. Okay, so Jorge says it will install us from a setup.py. Got you. Got you. So it needs a build chain. Yeah, I kind of suspected it would work, but it's kind of deprecated a lot of this stuff and moved toward, hey, I'm trying to, the optimized code path is I'm installing wheels out of PyPI or a PyPI, a private PyPI or something like that. Any other questions on UV? Yes. The UVX command is so there is a UVX command, and this is actually a shorthand command. It actually, I think this is like, I want to say it's UV tool run. Yeah. But you can just, instead of typing UV tool run, because you might want to run this all the time, you can say UVX, whatever the command is. And essentially this runs something, and I will get to the something. It can run a local script. It can run a script that is installed. It can run a script that is not installed. And it can run all of these, and it runs them in an isolated environment separate from the main project environment. That's kind of the core thing that it does. So for example, let's say I had a project, and I want to run something that formats my code. I want to have a code formatter or something. I don't want to declare the code formatter as a dependency of my project. You could, but you could also just say, I'm just going to run it one-off. And it also lets you kind of try something before you decide, I will make this kind of integrated into my project. I won't even declare it as a dev dependency. I will run it first, see what happens, and then if I like the output, then I will do it. So for example, this same people, Astral, they make a really fast Python code formatter called Rough, and they make a really fast Python type checker. If you do, Python has the optional typing. If you do those things, they have a fast code formatter and a fast type checker. For example, if you're like, let's see how good my type checking is on my project, you can just run the type checker without installing it, without anything. You can just run it, kind of see what happens on your project. If it's a Django project, it's bad. Real answer. Yeah, go ahead.
So maybe a non-standard question, but if you can use UV to run not locally available, let's say some if we through some deployment keys, can you possibly use UV to replace any installer script to avoid and run dynamically control based on paths or branches?
Okay, so the question was, can you use like UV's kind of one-off runner to run something out of a Git repo? I do not know, like without installing it. I do not know the answer to this. The only things I've ever used UVX to run were like PyPI packages. So I do not know the answer to that question. I kind of suspect it might work, but it would probably be kind of very verbose on the command line. Go ahead, Jorge. Right, yeah, you'd probably have to specify the full repo and the full tag, but I kind of think it would work. And then even, I think in that same format, you kind of have a hash at the end and then you can declare additional. Yeah, I think if you did that, I think it would work, but I've never done that. But I kind of suspect it would. You like it, okay. Yeah.
Probably one of the greatest tools to be released in the Python world in the last decade.
Yeah, I would agree. So yeah, I mean, UV has really upped the game of the Python packaging generally. So I completely agree with you. I mean, I don't want to say Python was falling behind, but you know, if you use some of these other tool chains in other languages, you kind of thought to yourself, oh, that would be nice to have something like that in Python, and then you didn't have one, but now you do, so it's great. Although there were always some things in, say, like NPM that I'm glad that they didn't implement. So, you know, yeah. Like, for example, in NPM, in JavaScript packages, you can have different dependencies, and they can have different versions of the same transitive dependency, and this is okay. In Python, you cannot have this. So you only have one installed version of a thing. But in JavaScript, it's the Wild West. You can do whatever you want. Not really, it's fine. Any other questions, last questions before we wrap up?
That new audit feature, that came from NPM probably, right?
I don't think so. I think, so pip tools had an audit feature, and I believe that the audit feature was designed after pip tools audit feature. Now, did pip tools audit feature come out of NPM? Maybe. I do not know the answer to that, because you are correct, the NPM has an audit feature. You're right. But I don't know the answer. I guess I don't know which came first. Yeah. Cool. I think that's it. I think that is essentially the meetup. Thank you for coming, I suppose. I guess I'm the last speaker and I'm the, and I'll just do the outro. So thank you for coming. I know this wasn't our usual spot. Hopefully we'll be back at the usual spot next month, but thank you for coming, and I'm glad you were all able to make it. This is actually a pretty good turnout, so thank you. Oh, and sign up to give a talk. And thanks to our speakers, thanks to Qualcomm, thanks to Cloudflare. Sign up to give a talk for next month. Really, yeah, do it. 100% survival rate of all speakers. Yeah, yeah, all right. Thank you, Hobson. Thanks for letting me use your laptop and everything. Yeah, I think that's it. Awesome. Thanks again for letting me use your laptop. And sorry I didn't get this on your talk. Yeah, that you know, there was like this really good, very long form article on supply chain attacks earlier in the month, and specifically how they work in the Python ecosystem. And yeah, we were on top of it at my company, and we're like, oh, like some of these things we were already doing, and then we're like, oh, these things like the exclude newer, because we'd had a bunch of like not supply chain vulnerabilities, but where like, oh, you know, we take like the very tippity tip edge, you know, if it's on the day we run our automated,
it's like rolling the dice.
Yeah, you know, like if the package breaks some other package,
Yeah.
like you have some problem for like a day or two until it rolls back. So we just decided, let's exclude everything newer than 2 weeks, and then like we're just not gonna have any problems.
Security, but just for, you know,
Yeah, we did it.
just for brittle packaging.
We ended up doing it because of security, but like we'd seen the issue with brittle packaging, but then you know that's gonna be a thing for security too. So yeah. Anyway, yeah. I guess I'll terminate the stream before I. Thank you.